Hello, guys, and welcome. I hope that you're doing well. My name is UHDking, or I play 4K, aka I play 8K, aka I play 16K. And in this video, we're going to continue on our research through the data towards the UHDking's ray tracing CPU benchmark application with the help of AI, artificial intelligence. This is going to be the part 3 of the research before we're going to start implementing the code and the research into the C# IDE. For those who didn't watch the part 1 and part 2, pretty much we are using the C# computer language, and with the help of AI we're trying to build an application when AI is going to explain to us and write the code, and then it's going to be first part as research, and then development will be when I am as software developer will go ahead and use the C# language IDE, will paste that code, and I will try to make an application with that code. Okay, and I'm going to share every single step-by-step process with you. Then we're going to test the code, develop the first runnable beta without any mistakes, and then we will use the AI again to advance the code and complete the final version of the application, and then I'm going to share it with you guys. So ultimate transparent processes while using the AI. You're going to learn a lot. I didn't know that I'm going to learn a lot myself. This is going to be my first application using the C# with the retracing capabilities. So I'm not a professional, but I already learned a lot because the AI helps us, and it is like 10 people behind my back with the help of AI and about 100 books. This is just unbelievable. In a couple hours, I learned so much about ray tracing and 3D rendering in real time throughout the research of part 1 and part 2. So hopefully this will be good as well. So today I'm using the OpenAI, and the AI is called ChatGPT. Okay, it's the free public version, first free public version from the January 9, 2023. As you can see on the bottom, I'm recording in real time. This video is not going to be scripted, so I'm going to go as we're gonna go together, and yeah, it's going to be a great ride, guys, especially if you're into software development, if you're graphics designer, 3D artist, gamer, PC hardware enthusiast, PC overclocker, because I'm trying to develop a software and create a value, and as my contribution to a community as a freeware, and it's going to be an application that's going to test your CPU. It's going to be oriented on CPU only. I know that retracing is best for the GPU because GPU can do 50 times as minimum faster than CPU. However, I'm trying to develop multi-threaded application as a test, as a benchmark, so we're gonna stress the CPU even in 2027 with 1000 CPU cores through the retracing, because retracing is very heavy process on CPU, and while utilizing every single core, every single thread, and test the CPU, and hopefully it's going to be as popular as 3D Mark, Future Mark, and a lot of people will pick up, and we're going to find out which computer is the fastest in terms of the CPU. And I am as a graphics designer, 3D artist, 3D animator, software developer, a system engineer, what else? PC hardware enthusiast, PC overclocker, a game developer, and a gamer. And I have a lot of experience over 10 years in every single field. So it's going to be a great gift by me, by UHDking, towards you, towards the community in all kind of different fields, and hopefully you're going to appreciate. At the same time, I'm learning the AI for the second year, and I'm trying to prove you a point that the senior developers, senior programmers will be no more in about couple months, and that's why you're going to see a lot of layoffs in IT companies. Not only the developers, not only software developers, not only the programmers, but in a lot of fields, musicians, physicians, attorneys will be replaced by the AI. And today I'm going to show you as a fact, as an example, while we're going to completely develop an application that will require at least 10 programmers and a lot of people in this topic, which is ray tracing, with a lot of knowledge behind their backs, but it's going to be done only with the AI and single developer, which is pretty much beginner in this field while creating ray tracing 3D rendering applications, okay, under the C#. But C# is my language. I pretty much familiar with the 6 computer languages, and I decided to go ahead and use the C# because I really like that language, and I will try to implement and use the C# and implement it towards different platforms in the future. I like it a little bit better than Java, but Java will be the better approach. However, C# is also a great approach because Microsoft is advancing this language, and very soon it's going to be deployable in all kind of different platforms, even on the mobile devices and all kind of mobile devices. Okay, so in part 2 we started with the creating the texture material in our trace ray. Go ahead and watch the part 1 and part 2. I will go ahead and include it in the video comments or video description to get familiar with the process. And this is, by the way, this is OpenAI.com website, ChatGPT version in January 2023. This is a free public version that was just released to the public like 2 months ago. Okay, and the AI over here is doing the research for us. At the same time, it's writing the code and explaining the code and explaining the technologies behind that code. Okay, like to babies. Keep in mind that this AI is a baby, but it's already as powerful as at least 10 human beings, very professional, like PhD level in the topic. It's just unbelievable, guys. So we started with the texture material, extending the code with the texture material so we can apply the texture as material instead of colors on our 3D primitive, 3D object. Okay, and as you can see, we were cut off by the AI. It asked us to wait 1 hour because it's cutting off after certain amount of requests because it's a free version. And what I learned, it's doing so because 1 AI request is equal to 10 or 100 Google requests in terms of the computer performance and power, how much is, and it's pretty much expensive. Okay, so that's why it's cutting you off for 1 hour and giving you to pause, a break, time for a break, while it's just doing millions right now requests in per second, and it's very expensive for this company. Okay, because it's a new thing and a lot of people are using it, and some people using for the stupid things, but I'm using it as a software developer in these examples and as a computer scientist. So let's go ahead and keep going, guys. So texture material, so material, okay, so AI told us it's worth noting that you need to implement the texture class in its sample method to sample the texture image. So we need to sample the texture image first. Also, you need to change the way of passing the material to the primitive to use primitive, which is 3D primitive, to use texture material instead of material. Okay, so we created class material, and now we gotta create texture material class. And as you can see, this is our trace ray class. It's extending it, and this is our texture material as material. Okay, and from part 2 you're gonna find out we just started with the extending the code while creating the texture ability or feature to apply to the 3D primitive instead of colors. Before we were applying the colors, we already created light, we created applying 3D primitives, colors to apply, and shadows. Okay, right now I'm creating the material. We created actually 2 lights. We created the second light after that, some features on the second light, and now it's a material. We just started and it's cut us off, and now the part 3 we coming back. So hopefully it's not going to cut us off. Hopefully this video will be for a couple hours, as again it's not going to be as fast as possible, but I will try to explain, I will try to read what AI is saying and try to explain my thoughts regarding this for the ultimate beginners, because I have some ideas, because as a 3D artist, 3D animator, graphics designer and software developer, so I will pretty much try to explain the way I understand it, and hopefully it's going to help to the beginners. So okay, so we need to, instead of material class with the texture material, I'm going to ask to use texture instead of material. Okay, it's created the texture material. In conclusion, to add texture as material that can be applied to 3D primitive in a ray tracing scene, in our 3D ray tracing scene, you can create a new class called texture material. It's created for us on top that inherits from the material class and use it. It's already done. So right here. So I'm assuming that you have a basic knowledge of the C# language, at least you understand the syntax. I'm not going to read the code yet, but it's a great idea when you're going to read the code. You know, I have limited time because I'm recording in real time and without a script. So I'm going to read what AI is saying, but you also, it's great when you're doing it on your own, you're going to read the code and you fully understand what's going on. I'm not going to test the code yet. It's going to be for the part one of the development, which will be multi-part of the videos, when we're going to implement the code in C# IDE under the Microsoft Visual Studio. I'm going to copy paste, and then we will start debugging the code, and we will create the application that will be runnable without any mistakes. It's going to be a videos when we're going to do that, but this is just a research yet, so that's why I'm not paying too much attention to the code. But it's a great idea when you're going to go step by step and implement the code and try the code. I'm not going to do that because it's going to require a lot of time, but I'm going to do that under the development. Okay, so in conclusion, to add texture as material that can be applied to 3D primitive in array tracing scene, you can create a new class called texture material that inherits the material class and use it in the trace ray, okay, method. Method is like function under different languages, but it's called method under the C#, along with the texture class to sample the texture image. So here's the trick, guys. You can always ask the continue AI. Keep in mind for those newcomers that AI has limited ability to output through us per single request in terms of the character. Sometimes it's stuck on something, you can see it. So always ask the continue, so it's going to continue, and it's, at the same time, even when it's done with the thought, maybe it's done with the thought, but if you're going to use the continue command in a 2023, at least in this free version of the ChatGPT in January 2023, is going to continue at the same time, finishing the thought. At the same time, it will also provide you an additional tips and some ideas. So it's a great idea to use continue a lot, this command. So throughout this video, as you can tell, I'm going to share a lot of ideas, a lot of tips, and a lot of knowledge that I already learned about the ChatGPT. So it's a great video for you guys to watch, just to learn something new if you into the AI as well. So a lot of information will be provided no matter what kind of field you are in. Okay, guys, I'm doing it on my own time and time and money. Nobody is supporting me, nobody is sponsoring me. So go ahead and smash that like button, share it with your friends if they're in similar interests, and support me, guys. All right, visit my sponsors. So I'm going to collect those pennies, and I'm going to do more videos like this, and we're going to learn more computer science besides the gameplays, 16K video resolution. By the way, I'm the pioneer on YouTube on 16K video resolution, 16K gameplays while playing games in 16K video resolution, which is 132.7 megapixels rendered in real time. I'm also creating some graphics design tutorials, 3D animation tutorials, and computer science tutorials. So today is a time about computer science tutorials for those folks. All kind of great valuable information over the UHDking.com, my YouTube channel. Alright, let's go ahead and read what it does for us. Look at this. It's just outputting a lot of information for us. In addition to the code mentioned above, keep in mind it's everything what's going on here in real time, and this is the real AI, and I believe this is not a fraud. This is the AI that created the computer science evolution in human lives, and guys, it's just unbelievable. It's going to change our life. This is what I believe as software developers, programmer, computer scientist, PC hardware enthusiast, graphics designer, 3D artist, and a good citizen. All right. So in addition to the code mentioned above, you can implement different texture mapping techniques to map the texture onto the 3D primitive. So of these techniques include UV mapping. This technique uses the UVW coordinates to map the texture onto the 3D primitive. Okay, this technique is commonly used for 3D models that have UVW coordinates already defined. So as you can see, it tells us some new terms and it's explaining the terms, which is great for the beginners. But as again, you can define every single term and you can find out everything. AI can explain that term even for your dog or for your cat. Keep that in mind. But I'm going to define because as again, we are limited for like 50 or 100 requests per some amount of time daily per user, and I'm not gonna do that because it's gonna cut us off. I'm trying to create as informative video as possible for our approach to our goal. So, but you can, when you're doing it on your own, you can define every single term, but it's going to take you a longer time because AI will cut you off. As again, this is the free version. That's why I believe that it's going to be ChatGPT Pro version when it's not going to cut you off, but it's going to cost you a monthly fee. By the way, I'm sipping some hot chocolate and a coffee. Not very healthy drink, but to keep me energetic because it's already at night. It's what? It's 2 a.m. Wow, 2 a.m. And the best drink will be tea with 2 lemons, or the best will be water with 2 lemons. Clean water with 2 lemons is the best to clean your body. Do not drink alcohol or do not smoke. And the audio track that is playing on the background is all rights reserved. There is no royalties can be claimed. I have the commercial license. Okay, let's continue, guys. So spherical mapping. So all kind of different mapping, as you can see. So I'm learning it as well because I didn't know all of this even as 3D artist, 3D animator. A lot of information from part 1 and part 2 I learned myself as well. Pretty much it's like 10 books was compressed into us in 2 hours, and about 10 professionals was explaining it to us throughout part 1 and part 2. Hopefully it's going to be through this part 3. So there's another technique which is spherical mapping to set the texture, which is image, which is bitmap, on a 3D primitive or 3D object in our 3D scene of retracing that's going to support the retracing capabilities. And as again, it's better to do it on GPU, but I'm doing it on CPU just to stress the system because it's going to be a benchmark to stress all available cores, and the test will be long, so I don't care about the speed. I care about the quality, and it could be 10-15 minutes on today's systems. So it's I would say even 20 minutes on today's system, so it's gonna cut out in 2027 up to 1 minute or maybe 30 seconds, and we're gonna find out how the technology improved in terms of the CPU capabilities on your devices. So second method, spherical mapping. The technique, let me actually highlight what I'm reading. The technique maps the texture onto the 3D primitive as if it were wrapped around a sphere. Okay, this technique is commonly used for objects that have, or primitives I would say, that have a spherical shape such as spheres or planets. Okay, cylindrical mapping. This technique maps the texture onto the 3D primitive as if it were wrapped around a cylinder. This technique is commonly used for objects that have a cylindrical shape, such as cylinders or columns. Planar mapping. This technique maps the texture onto the 3D primitive as it were on a flat plane. This technique is commonly used for objects that have a flat shape, such as wall or floors. Makes sense. So pretty much we already got some clues which techniques we're going to use for which 3D objects, okay, while applying the texture. You can implement these techniques by using different formulas to calculate the UVW coordinates in the shade method of the texture material class. Okay, we need to create that shade method. We don't have under texture material class. It's worth noting that the best texture mapping technique will depend on the specific requirements of your project and the characteristic of the 3D primitive you're trying to map the texture onto. You may need to experiment with the different techniques to find the best balance between the quality and performance. In conclusion, to add texture as material that can be applied to 3D primitive in a ray tracing scene, you can create a new class called texture material that inherits from the material class and use it in the trace ray method along with the texture class to sample the texture image. You can also implement different texture mapping techniques such as UV mapping, spherical mapping, cylinder mapping, planar mapping to map the texture onto the 3D primitive. The best texture mapping technique will depend on the specific requirements of your project and characteristic of the 3D primitive you're trying to map into the texture. As again, let's go ahead and gather a lot of information as we could. I don't think it's everything what AI can provide to us, so I'm gonna say continue. Let's go ahead and have a look. When it takes some time, when it's thinking like this, I think it's getting some new requests, and this is very expensive. And instead of 100 requests per 2 hours, you can do 10 or 15. So be careful. But this information will be very unique, and AI pretty much can see what it already displayed to us, and it's gonna gather some new information that will be valuable as it thinks. Okay, based on the input it's already provided. And it's always to use the continue as much as you can to gather as much information as you can for your project. Okay, let's go ahead and start reading. Another important aspect of adding texture to a 3D primitive in a ray tracing scene is the handling of texture filtering and repeat mode. Texture filtering is the technique used to smooth the edges of the texture when it's mapped onto the 3D primitive. Repeat mode is the technique used to handle the texture when it's mapped outside the UVW coordinates. There are different types of texture filtering techniques such as nearest neighbor. Let me get to the top. So I'm reading right here. Nearest neighbor filtering. The technique uses the color of the closest texel to the UVW coordinates. This technique is fast but can produce a blocky or pixelated image. Okay, we don't care about fast techniques. Anyways, bilinear filtering, another method. This technique uses the average color of the 4 closest texels to the UVW coordinates. The technique is slower than nearest neighbor filtering but produces a smoother image. So yeah, you probably heard about those when you're doing the image compression or even in computer games under video settings. Sometimes some game developers including those type of settings for you under the advanced option or custom option. You most likely you heard the trilinear filtering or bilinear filtering. So which is the third method as AI showing to us. Trilinear filtering. This technique uses the combination of bilinear filtering and MIP mapping. MIP mapping is a technique that uses multiple versions of the texture image at a different resolution to improve performance and reduce aliasing. Okay, so aliasing, it's when, let's say, when you have the sphere that was drawn by the line, just because we are using pixels, you're gonna see it's made out of this kind of pixels, and the edges will be hard. It's not going to be like a line, like a circle. It's going to be made up of the like a squares. So to make sure it's going to be much better like a line for your eye, you got to use the aliasing, okay, anti-aliasing method, which will reduce the aliasing. Okay, there are different types of repeat mode techniques such as clamp. This technique clamps the UVW coordinates to the edge of the texture that can cause visible seams where the texture is mapped into the 3D primitive. Repeat. The technique repeats the texture when the UVW coordinates are outside of the range of the texture. This can cause visible seams where the texture is mapped onto the 3D primitive. Mirror. This technique mirrors the texture when the UVW coordinates are outside the range of the texture. This can cause visible seams where the texture is mapped onto the 3D primitive. You can implement these techniques by adding properties to the text material class, such as filtering mode and repeat mode, and use them in a sample method of the texture class. It's worth noting that the best texture filtering and repeat mode technique will depend on the specific requirements of your project and the characteristic of the scene you are rendering. You may need to experiment with the different techniques to find the best balance between quality and performance. In conclusion, to add textures to a 3D primitive in a ray tracing scene, it is important to handle the texture filtering and repeat mode. There are different types of texture filtering and repeat mode techniques, such as nearest neighbor filtering, bilinear filtering, trilinear filtering, clamp, repeat, and mirror. The best technique will depend on the specific requirements of your project and the characteristics of the scene you're rendering. You may need to experiment with the different techniques to find the best balance between quality and performance. Okay, but it didn't do any code for us. So what I'm gonna do first, let's go ahead and make sure that it does the code for us. So what I'm gonna do, I'm gonna ask the AI, create a new class called text material that inherits from the material class and use it in trace method along with the texture class to sample the texture image. I'm going to ask it what AI told us to do. It's a great idea to ask it, to manipulate it, and it's going to do that for us, so you don't have to do it yourself. This is another technique for you. And then implement these techniques by using different formulas, data. I'm going to copy this as well, so it's going to create the code for us, so don't have to guess. It's great for the beginners as well. As again, guys, I'm not going to repeat myself. Go ahead and please watch the part 1 and part 2. I already explained to you how why I'm using this type of approach for the AI. Pretty much is going to give us the best answers, okay? When I'm going to ask AI, what is ask us at the same time, and it's going to go ahead and do it. Okay, and shade, data, and now add texture as material that can apply to We already do that. Already asked that, and the last thing, sample. I don't think we did the sample yet, so you can implement. I'm gonna ask implement these techniques by adding data. I don't think we are ask it. Implement the called text material inherent to the class data. Implement these techniques data. So I'm gonna put it here. So I'm gonna say implement. So AI is gonna start writing the code for us. Keep in mind, as again, when AI is going to do a mistake after a couple tries, because it can see the code on top when it's going to provide the code for us, and if it's going to see it did the mistake, it's going to tell us, I did a mistake, here's the new version. It's great because it's checking itself. Create a new class, so it's supposed to type. I probably should say not create, extend. I should ask to extend it. As you can see, perfect C# code, including the perfect comments. This is just unbelievable, and perfect naming of the variables or methods or even class. So right now it's extending the material class with texture material, as you can see. Because again, guys, this is not going to be scripted, so I'm going to comment as we're gonna go in real time, and there is a possibility I'm going to make any mistakes, or some mistakes, and English is not my first language, but this video will be a great to watch, and this video will be great to watch even if you're not going to duplicate this experience, just to learn the new things, because you're going to learn a lot about 3D as a 3D artist, graphic designer, or even a gamer. Because a lot of this technologies are used in computer games, and a lot of gamers are watching my channel. So as you can see, it closed that class that I created. In this example, the texture material class, and now it's stuck. So we're gonna ask continue, and it's gonna continue because it's output to us some limited amount of characters. They're doing that just to save the resources. They're not gonna output everything what AI thinks to answer the question, but limited amount of characters, because as again it makes sense, because million requests from a lot of users, so they're trying to save the resources. It's supposed to continue. In this example, the texture material class has, and now it's going to continue, has traditional properties such as texture, UVW, filtering, and repeat. So we already know about those modes. It's explaining to us on top. To store the texture image, the UVW coordinates of the texture, the filtering mode, and repeat mode. So all those methods are used here. The shade method, it's also used the shade method. The shade method of the texture material class first calculates the UVW coordinates of the intersection point, and then handles the repeat mode based on the repeat property. It then samples the texture at the UVW coordinates using the sample method of the texture class and passes the filtering property. Finally, it applies the texture color to the final color by multiplying it with the base shade method. You can use this texture material class in the trace ray method to apply the texture to the 3D primitive. But I don't see the point where I can use the image or a picture as a texture. I'm gonna ask it to extend the code when I can open an image and apply as a texture. Worth noting, then it's just did the code for us, as you can see, and it's closed that, so it's perfect. It's worth noting that you should also update the texture class to handle the filtering mode and repeat mode in the sample method. I don't see the sample method here. I'm gonna ask for the AI to update the texture class to handle the filtering mode. In conclusion, so we're gonna ask the AI to do that and see the sample of the code. In conclusion, you can create a new class called texture material that inherits from the material class and use it in the trace ray method along with the texture class to sample the texture image. Implement these techniques by adding properties to the texture material class such as filtering mode and repeat mode, and use them in the sample mode of the texture class. Implement these techniques by using different formulas to calculate the UVW coordinates in the shade method of the texture material class. I don't see the sample method. This is trace ray method. Where is the sample method? This is a shade method. I don't see the sample method. It didn't create the sample method for us. So let's go ahead and see what it's talking about in terms of the code, so we don't have to guess as we go. So what I'm gonna say, update the texture class as it asks us to do. I'm gonna ask it to do. So it's gonna do that, and create a new class called data to sample the texture image. Implement it by adding properties data. Implement these techniques by using different formulas to calculate data. I think it's already shown it to us, but let's go ahead and ask the AI just to make sure that we receive that. So I'm gonna say update. Then I'm going to say create. So give us a clue that we can do it, but I'm gonna ask the AI to do it for us. Sure, here's an example of our data texture class that handles the filtering mode and repeat mode in its sample method. Here's the sample method now. We can see the sample method. Public bitmap image. So that bitmap image, could be, guys, as the image that we're gonna load from the class that opens the file as the image, and we're gonna pass the parameters into that bitmap image. So this is we gotta create like open dialog using the file system of the C#, and it's going to open the image, and then we're gonna pass the parameters to the public bitmap image. This is what I'm assuming, because it doesn't know what kind of image we're gonna pass, so it doesn't know. So you gotta do it with the code. First you gotta open the dialog, open and save dialog in C#, and you're gonna pull up that file name that user will select, and then you're gonna equal to bitmap image, and then you're gonna manipulate that bitmap image in the code down below. Hopefully, guys, this makes sense. To sample that image as it asks us to do. Look at this, it's using the sample nearest and sample bilinear methods as it's explained to us, but there is nothing there. I'm gonna ask it, it just put the like it's commented, but nothing to comment. So most likely it's gonna tell us. As you can see, it stopped. So I'm gonna ask it continue, and then we're gonna update that code, make sure that we receive those methods: sample nearest methods, sample bilinear method, and sample linear method. Not just a comment with nothing, which is empty methods, but where AI actually going to go ahead and sample the pixels of that image as a texture. So it's stuck. So when it stucks like this, always use the continue. So it's gonna continue the thought, as again you understand why, because it's limited in terms of the characters it can output per request, just to save the resources of its OpenAI company resources, of its computing power, because a lot of people using it, millions of people right now is using it, and most likely they didn't have enough resources because they started with zero. Right now they got like 40 billions in the end of January 2023, 40 billions of investments, and I believe they're going to invest it towards the computer performance power, and it's going to speed up. Okay, it's thinking, guys. In this example, the texture class has a property image that stores the texture image. The sample method takes the UVW coordinates and filtering mode as input, and first handles the repeat mode. Ooh, cut us out, guys. Hopefully not. It didn't finish. It didn't finish the request. This was an error. Come on. Oh my goodness. It just cut us off, guys. That was error generating a response. Okay, well, it's great to refresh it. As you can see, I'm trying to refresh it, but sometimes it works, sometimes it doesn't. Come on. Let me type hi here. Hopefully it's going to refresh it. Here we go. Now I'm gonna get back to that chat and hopefully we can. There's an error and it stopped. Something is going on, guys. Oh my goodness. I hope that come on, guys. We probably limited in terms of the look at this. We cannot even scroll down. There is something going on. Here we go. Page down. Page down is working. Doesn't work that much. As you can see, they're using the JavaScript and this very bad approach. They thinking that you're on a mobile device trying to save your some resources. But it's impossible to save it as PDF. So it's hopefully they're gonna create an option to save it as PDF as research, so you can study it offline. But anyways, this is where it went, and I ask it to continue and it stopped. Come on. Can I save and submit? Can we save and submit? Here we go. This is how you fix it. Thanks God, Jesus. It's taking that long. In this example, the texture class has a property image to store the texture image and a method sample that makes in the UVW coordinates and filtering mode as input. The sample method first handles the repeat mode based on the repeat property in the same way as the shade method in the texture material class. Next, it handles the filtering mode based on the filtering input, and finally it calls the corresponding sample method, nearest neighbor, bilinear or trilinear method. Okay, you can use this texture class in a texture material class to sample the texture image, but while using those methods it put the comments and it's empty method. So I'm going to ask the AI to finish the method because it's just nothing in there, it's just empty method. It is worth noting that sample nearest, sample bilinear, and sample trilinear methods should be implemented with the corresponding formulas to sample the texture image accordingly. In conclusion, you can update the texture class to handle filtering mode and repeat mode in its sample method. Create new class called texture material that inherits from the material class, so it's going to extend the material class, and use it in a trace ray method along with the texture class to sample the texture image. Implement these techniques by adding properties to the texture material class such as filtering mode and repeat mode, and use them in the sample method of the texture class. Implement these techniques by using different formulas to calculate the UVW coordinates in the shade method of the texture material class. Okay, I'm going to ask it to complete for us, to extend code with examples of these methods, because as you can tell, those type of methods are empty. Let me show it to you right here. He just created some comments with the dots and nothing in there. So I'm gonna ask extend the code with methods that demonstrate the functionality. While sample the texture image accordingly. I'm gonna copy and paste this one. It's always a great idea when it's overloaded, when service is overloaded, you Control A and Control C so you don't have to type it again. Let's see, it's gonna create some additional code for us. It's gonna actually create those methods that are not going to be empty. I probably should sample nearest, sample bilinear, and sample trilinear in the quotes. But let's see. Sure, here's an example of implementation of the sample nearest, sample bilinear, and sample trilinear methods in the texture class that demonstrates how to sample the texture image accordingly. Okay, now it's creating the method for us. Good, good, good. So as you can see, as again, you gotta know a basic knowledge. And it's best for you to look at the code, study the code, and understand additionally how to ask the question properly, just in case one is going to create like it did it. Tell us that it created the class, the method of the sample nearest, sample bilinear, and etc. But it actually didn't create it. It was just created as empty class, empty method. So methods. So it's nice to ask it so you don't have to type it in. It's going to show you an example, and then you can copy and paste. Look at this. I even didn't know what it is to begin with, so I couldn't complete those. And as you saw, it did like dots, dots, dots for us, empty methods. And now it's explained to us. Now it's stopped. So what I'm gonna do, I'm going to ask it to continue, of course. Let's wait. I think it's still thinking. If it's not going to proceed, yep. As you can see, when it's blinking, the cursor, it's still thinking. And then I'm gonna ask to continue. I couldn't do that, guys. This is because, as again, I'm beginner for the retracing. I read one book and I was following the Polish developer, software developer that created the Java retracer, but it wasn't fully multi-threaded. And over here we're creating fully multi-threaded on a C#, and not just basic like that Polish developer did. He claims he learned it from the book by the Pixar and additional book by the software developer. I only read the Pixar, the short version of it. But as you can see, AI explaining us like 100 books. It's like almost 100 different professionals in the field, like 3D artists, people that knowledgeable, software developers, and it's like everything just by AI. And guys, in a couple hours you can receive so much knowledge. This is just unbelievable, guys. I cannot believe what it is. Hopefully you're also impressed, and hopefully you also learned a lot of things. If you did, go ahead and smash that like button, share it with your friends. As again, let's go ahead and continue. As you can see, it's stuck right now. It doesn't have that flashing cursor, and I'm gonna ask continue, of course, and it's gonna continue. So in this example, the sample nearest method takes the UVW coordinates as input and calculates the nearest texel by rounding the UVW coordinates to the nearest integer. I even don't know what is the texel, to be honest with you. You can ask, define the texel, and it's going to do that. But as again, I don't want to waste my request. The sample bilinear, we're gonna find out later on what it is. The sample bilinear method takes the UVW coordinates as input and calculates the final color by weighting the 4 nearest texels using the bilinear interpolation method. I believe texel is like probably similar to the pixel. The sample trilinear method is not implemented here, but it can be implemented using the trilinear interpolation method. I'm going to ask it to implement it for us. It's not implemented, but let's go ahead and ask it to implement it. So under the custom options, we will give to the user that's going to use our application to use all kind of different presets and features as a custom presets, besides our own benchmark that's going to be default for all the users. But I'm going to create a custom benchmark for the user, whatever they feel to. The idea is to apply the linear interpolation method in each map level and take the final result by weighting the results of each level. Because a lot of things may not make a lot of sense to you until you're going to start implementing the code and play with the code, as AI advised in part 1 and part 2. So it's a great idea, and that type of approach will make a clear sense to you, even if you do not understand by reading the explanation. It's worth noting that the sample nearest method uses the getPixel method of the bitmap class, and bitmap class is going to load the image of the texture, which is relatively slow. If you need to sample a large number of, okay, we ask continue. If you need to sample a large number of pixels, it's recommended use the faster methods such as log bits to access not the bitmap but log bits. I even didn't know about the log bits, guys. I know the bitmap class under the C#, it's a native class of the C#, but log bits, check it out, to access the underlying pixel data directly, or use a custom image data structure to store the texture image. I have no idea about this. We're gonna ask it to explain to us. It's also worth noting that the sample trilinear method requires generating multiple, so that's why I didn't put it for us, map levels of the texture image and storing them into data structure that supports easy access to each level. I'm going to ask the AI to extend the code with sample trilinear. It's trying to cheat at us. Look like it's a lot of data and advanced approach, and we need to have it. In conclusion, you can extend the code by adding the sample nearest, sample ability, and sample trilinear methods to a texture class. I'm going to ask the AI to do that. These methods demonstrate how to sample the texture image accordingly. The sample nearest method select the nearest texel by rounding the UVW coordinates to the nearest integer. The sample ability method calculates the final color by weighting the 4 nearest texel using bilinear interpolation, and the sample trilinear method calculates the final color by weighting the results of the bilinear interpolation in multiple maps levels using trilinear interpolation. So it's kind of all kind of different three approaches, okay? But it didn't finish for us the sample trilinear. It's cheated. It did again empty method. So I'm going to ask the AI to extend the code with the data okay, and then let's go ahead and copy that. I'm gonna say extend the code with example, extend the code with working example, the code with working example, example of data, okay, of the sample nearest sample bilinear and sample trilinear, okay, and then I will ask that log bits and use a faster method such as log bits to access the underlying pixel data directly, as the AI told us, or use a custom image data structure to store the texture image. Let's go ahead and ask it. I never heard that log bits. I have no idea what it is. Maybe it's dependencies, some of APIs. And as again, you can ask, define the log bits, and AI will explain it to you. Especially if you're going to do it in this chat, because it's going to aware of what it is and why it needs to define. Otherwise, it can ask, there could be all kind of different log bits. Keep that in mind. Let's go ahead and ask it. Sure, here's an example of implementation, It's already done for us sample nearest and sample bilinear, but never done the sample trilinear. So hopefully it's not going to cheat this time. As you can see, it's using the bitmap class as image. And now it's using the log bits, okay. Now it's creating the sample nearest. It's already done for us. And it did the sample bilinear method, but it cheated on sample trilinear method. So hopefully it's not going to do it this time. It's going to write for us. Guys, I have a feeling that we're going to complete the whole application after this research without any single problem. So hopefully this is going to be the last part of the research, the third part. And then we're going to switch to the development part. It's going to be also a couple parts, maybe 2 or 3 parts or even more of the video. Then we're going to develop and test it at the same time under the C# IDE such as Microsoft Visual Studio. And then I will try the AI to extend that code, to advance the code after we will receive the first beta for even better version of the application. And then we're going to conclude this final version, and I'm going to redistribute it for you guys under UHDking, and hopefully it's going to be popular. So support me. As you can see, it stopped, so we're going to ask continue. It stopped on that method, which is the sample trilinear method. I'm going to ask continue, so hopefully it's going to finish for us. So hopefully it's not going to cheat this time. It's not cheating, but it's not typing in a black box. Sometimes it does it, so you gotta use that code, that typing not in a black box. This is the code, this is the real code. It's corrected itself. But as again, this is a problem on the backend server, while it's through some JavaScript when it's converted into the front end for the front end user, and it does sometimes those type of mistakes. So hopefully they're gonna fix it. When it's outputting the responses, sometimes it's doing a mistake. It should doing in the black box, but it doesn't do it. It's just outputting, as you can see, on a white space. Right now, this is the node, as again should be in the code. This should be on a white space, because if you're gonna use this as part of the code, C# will generate an error on every single word. If you're not gonna comment this, you gotta comment this. But this is what he's explaining for us. This is not part of the C# code. But if you're going to copy and paste it, let's say if you're beginner, if you do not understand it, as again, it's going to pretty much, the debugger will stop you on every single word. Alright, so at least it's completed that. Let's see that method. Here we go, this sample trilinear method is completed and it's closed right here. So this is going to be the code of that method. It should be in black box, but anyways. And okay, so tell us, in this example, the texture class constructor uses the lock bits method to lock image data in memory and copy it to the private byte array, which is used to access the pixels data in the sample nearest, sample bilinear, and sample trilinear methods. This method is faster than the getPixel method of the bitmap class. So it shows us 2 different methods that we can use, and most likely I'm going to use that lock bits, because look like that lock bits method is part of the C# itself, dependencies of the C# dependencies without using any APIs, which is great. It's going to be fast and part of the C#, so why not? It's going to be deployable to multiple devices on multiple platforms that supports the C#. The sample nearest method selects the nearest texel by rounding the UVW coordinates to the nearest integer. The sample bilinear method calculates the final color by weighting the 4 nearest texels using bilinear interpolation, and the sample trilinear method calculates the final color by weighting the results of the bilinear interpolation in multiple mid-map levels using trilinear interpolation. Here the mid-map levels is calculated using the lambda variable, and the getPixel method is used to return the color value of the selected pixel. Okay, worth noting that the LockBits method is only available for the bitmap class, and it requires the image to be in format 32-bit RGB B pixels. If you use a different image data structure, like a different format and data structure of that format, you should implement your own method to access the pixel data directly. I'm gonna ask for the AI to do that. I'm gonna ask implement method to access the pixel data directly for. So this is how you ask the questions if you want to get great results, and results that you don't have to think a lot if you're lazy, or if you're not knowledgeable about the topic, such as me, because I have no idea what it's talking about. But we're gonna find out when we're gonna start implementing the code. It's going to be getting much clearer for us. So implement your own implement method, example method, I'm gonna say example method, to access the pixel data directly from the image that is not data from an image that is not that has a different image data structure that has a different image data structure that is not in a format of 32-bit data data data, that is structure that is not in a format of 32 pixels. Okay, let's go ahead and ask it. Over here I did a mistake. Let's correct that. Okay, completely makes sense. Let's go ahead and ask it. So I ask it, implement your example method to access the pixel data from image that has a different image data structure that is not in a format of 32-bit ARGB pixels. Just in case if the image as a texture will be in different pixel format, has different data structure. Let's go ahead and have a look. So tell us that we can create our own method, but I have no idea how to do that. So that's why we're gonna ask the AI to do that, because he is the one who is the smartest over here. Okay. let me copy this, what we learned by pressing on this icon right here. You can save and submit. Let's go ahead and save and submit. Maybe it's going to fix itself. Yep, it does. So I think it's just overloaded its resources of the OpenAI company. That's why it was an error. So you gotta use your, intellect to understand why there is an error as well, as you can see. So hopefully in the future AI will tell us why there is an error. It was, I think, internal error. Sure, here's an example of a method, internal error on the server probably, and now it's just getting right. Sure, here's an example of a method that can be used to access the pixel data from an image with a different data structure that is not in the format of 32-bit ARGB pixels, because I have no idea what it's talking about. So now it's gonna show us an example, which is nice. It's a custom image, probably different formats that is not custom image format that is not in that data structure. In this example, the custom image class stores the image data in private byte array along with the width, height, and number of channels. The getPixel method takes the x and y coordinates of the pixel as input and calculates the position of the pixel in the data array based on the width, height, and number of channels of the image. The method then returns the color value of the selected pixels. This method can be used for any image data structure that stores the pixel data in a linear array where each channel of the pixel is stored contiguously. It's worth noting that for this method, the channel's value need to be passed during the initialization of the object, and the method is not multi-thread safe. Okay, so this method is not multi-thread safe. Let's ask continue. Maybe it's gonna give us a clue of the multi-thread safe. If not, I'm gonna ask two questions. First, give me an example. What is the image that's using the 32-bit ARGB pixels or the image format? So we're gonna know. We're gonna have a clue for our research. And what is the other method that use the image formats as example that using all kind of that is not in that format? So we're gonna know which will be the format as it told us in linear array, that using the pixel data in linear array. I'm gonna ask an example of the image formats, okay, that can be stored the data in that type of linear array. I have no idea what it is. I'm not so into that, into the formats of the pixel storing data arrays. So we're gonna find out. So first of all, I'm gonna ask continue. See what AI will advise us. I'm pretty sure when it's doing something like that, it's gonna have a solution how to do things better, because this method is not multi-thread, and then I'm gonna ask to provide a better multi-thread safe option as well, because as again I'm creating the application that's supposed to be multi-threaded. This is important because I'm going to utilize all the available threads on the CPU, and I'm planning to utilize it, I believe, as again Windows 10 professional supports below 600 CPU threads, I believe, but Windows 11 supports, I believe, all the way to 2000 if I'm not mistaken. But we're going to ask the AI to find out for sure. To make the getPixel method multi-thread safe, as you can see, it's advised us. So I was right. It's advised us to create this safe multi-thread method. You can use the lock statement to synchronize access to the data array. So it's give us a solution, which is great. So as you can see, AI is such a smart guys. It's like so many developers that constantly advising us, so many professionals that constantly advising us, and it's right. You cannot get it right without that human factor stupidity or something like that without wasting any time, and it's going to be correct, guys. 99.9%. As again, I developed already 2 short apps using AI, and it was 0 mistakes. It was unbelievable. Just a few that was solvable under the debugging tool of the C# IDE. It was easy to see if you at least a beginner and you understand the syntax and such. Anyways, to make the getPixel method multi-thread safe, you can use the log statement to synchronize access to the data array. Here's an example of how to do this. Okay, so we're gonna use, so it's created a much better custom image, which is single-threaded or multi-threaded but not safe, and this is going to be another example which will be multi-threaded but safe. So this is what I'm gonna use. But at least it gave us 2 different codes, but this one I'm going to use. Another approach is to use memory map file class. Wow, this is something new, never used that class before, which allows multiple processes to access the same memory. This will make the meta thread safe and also improve the performance, but this approach is more complex than the previous one. I'm going to ask it to give us an example. In conclusion, you can use the getPixel method of the custom image class to access the pixel data from an image with a different data structure by passing the x and y coordinates of the pixel as input and returning the color value of the selected pixels. To make the method multi-thread safe, you can use the log statement or memory map file class to synchronize access to the data array. So I believe if I'm going to ask continue, always scroll down to the bottom just to make sure this is done. If I'm going to ask continue, it's going to actually give us an example, I think. AI is such a smart. So let's go ahead and have a look. It's going to give us the code snippet, I think. I apologize, but it seems I have misunderstood your request to create multi-thread ray tracing example that utilize every thread and 100% is complex task. It requires a good understanding of parallel programming. So right now it's putting that human being factor to us, like blah 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 blah, no resolution, blah blah blah, and it's trying, as again as I explained to you, it's trying to be as a human being to us, and gonna get psychologically to you, but to understand that and cut it out. So there is no solution, just re-ask the question in different ways, manipulate the question, and this is what we're gonna do. So this is what they ask us. I apologize, but it seems I have misunderstood your request to create a multi-threaded ray tracing example that utilizes every thread at 100% is a complex task. It requires a good understanding of parallel programming and computer graphics. Every time it tells you that, get help or something like that, or read some books, it's total blah blah blah, and just re-ask the question in a different way. I have provided you with an example of how to implement some of the core features of basic ray tracer. Basic for now, but you're gonna advance it AI later on after I'm gonna test it. Alright guys, I already explained it to you. We're gonna advance the code after we will do the beta testing, successfully develop application, and how to extend it with the additional functionality such as texture mapping, and how to access the pixel data from the image with a different data structure. But I apologize for not providing you an example of a complete multi-thread ray tracer that utilizes every thread at 100%. However, I can provide you with some, so it's already know its mistakes. It studied code on top, as again, if it's gonna do any mistakes, it's gonna let you know, and it's gonna let you know how to fix it. However, I can provide you with some general tips of how to optimize your ray tracing code for performance and make use of all available threads. Use parallelism in the rendering loop instead of processing each pixel sequentially. You can use the pt.3of4 method to process multi-pixels in parallel. It's already told us this, so it's kind of trying to optimize it. So it's focused right now on optimization. Okay, we're gonna optimize the code while we're gonna advance the code. Okay, so we don't care about this right now. Use SIMD instructions. Modern CPU has instructions that can perform multiple operations at the same time. You can use this system, numeric vectors, namespace to take advantage of them. Use multi-level parallelism. You use a combination of parallelism in the rendering loop. Use SIMD instructions and use the GPU, no GPU, sorry buddy, to perform the ray tracing. Load balancing makes sure that all threads are working evenly. This can be achieved by dividing the image into smaller tiles and distributing them evenly among all threads. Okay, this is great. Avoid contention. Try to minimize the number of shared resources and avoid locking when accessing shared data. Profiling and optimization. Use a profiler to identify performance bottlenecks and optimize the critical parts of your code. So you gotta test it, you gotta debug it, you gotta test it while you're gonna develop it, and see the performance as AI advice in part 2 for us. This type of approaches and smart approaches as software developer. Beta test it as well as you developing it. Do that. Current programming languages allow us to do it. Data structures optimization. The data structure that is used to store the scene data can affect the performance. Consider using different data structures such as BVH and kt.3 or OCT3 to optimize the performance. Never done so don't know how to do it, but we can ask the AI to do that. Memory optimization. Minimize the number of memory allocation and use the memory pooling to avoid memory fragmentation. Please let me know if there is anything else I can help you with. So it's kind of done, as you can see, and it makes sense. So it's kind of summarize it for us. So we gotta ask questions now, and I'm gonna ask the question. I'm gonna ask the AI to do it for us. So I really love the method, not the GPU one, but the method that load balancing. Make sure all threads are working evenly. This can be achieved by dividing the image into smaller tiles. I'm going to ask the AI to do that for us and distributing them evenly among all threads. I'm going to ask an example. Okay, so and then you use parallelism in the rendering loop. Parallelism in the rendering loop. Instead of processing each pixel sequentially, you can use parallel 4 method to process multiple pixels in parallel. Okay. Okay, so what I'm gonna do, I'm gonna ask, provide extend the code with an example. Extend the code with an example of parallelism in a rendering loop. I'm gonna be so smart. Check it out. Extend the code for the example of parallelism in the rendering loop, while use this method to process parallel 4 method to process multiple pixels in parallel, while use the parallel 4. I better put this single quote just to make sure AI understands. But AI is so smart, it even understands without it, which is unbelievable, guys. So this is not the fraud, this is the real AI. That is, again, this is the real IT, computer science evolution, and it's going to pretty much put us on another level, guys. You will see it in the year of 2023, 2024. A lot of companies will adopt this through the chats. They're going to use this AI not only for the development of the softwares, but to help you through the chats as customer support. They're gonna do all kind of good things, as well as even implementing the tips and clue helper in their software, they're going to give you exactly what you need to look. If you're a beginner of their software, let's say, a helper. All kind of different AIs will be, but this AI will be implemented, and you can use already the plugin of the ChatGPT or plugins of the OpenAI technologies into your application as API. So they're gonna use it a lot, guys. This type of functionality of the AI in third-party applications by third-party companies. You will see it a lot, guys, in the end of 2023. So a lot of people will lose the job because it will be replaced by this. And as again, I believe it's going to be AI administrator fields, AI management fields, people that will be knowledgeable on the topic, but will have the ability to ask the AI, control the AI, and use the responses of the AI and create the final to summarize it as application or the services. You will see it. It's going to be a new field as again AI administrator and AI managers, as I already explained it to you. But however, let's go ahead and ask the question. So method to process multiple pixels in parallel. So it's going to show us an example. Or I'm going to ask, check it out, I'm going to be so smart as a human being. Or extend code with an example of load balancing as ask us to do, because I have no idea what it's telling us, even as developer in C# over 5 years. Load balancing, make sure all threads are working evenly. This load balancing, and then I'm gonna put it like this. Oops, sorry guys, 1 second. I'm asking such a tricky question, so hopefully AI is not gonna cut us out. If it's gonna cut us out, guys, right now, a couple more requests, then it's going to be part 4, because I'm not finished with my researches yet. I'm trying to gather as much code as possible, as much as responses, as much as information possible, and then I will proceed with the development stages, and it's going to be under the playlist development stages available over the UHDking YouTube channel. Or hold on 1 second, make sure all the threads evenly, just like AI want us. So we're gonna ask AI what it's told us to do and give us an example, but in such a tricky request. Evenly, okay, by dividing an image into smaller tiles and distributing them evenly among all threads. So evenly, let me by like that, and I'm gonna ask the AI use the best method as example as you think will be the best for multi-threaded. Well, as you think will be the best example for multi-threaded approach. Okay, so now it's gonna give us an example of the code. You will see it's going to be amazing. Let's go now. Look, this is such a smart question. So I'm gonna ask, extend the code with an example of parallelism in the rendering loop while use the parallel for method to process multiple pixels in parallel, or extend the code with example of load balancing as it told us to do, because I have no idea how to do either. and it's better for the AI. Show us an example. Make sure that all threads are working evenly by dividing an image into smaller tiles, as the AI told us, and distributing them evenly among all threads. So I rephrase it and I use the AI responses and I manipulate the next request to get the best possible idea as a software developer and an example in form of the code. So hopefully guys this makes sense. Use the best method as an example as you think will be the best example for multi-threaded approach. Okay, let's go ahead and click that, and this is sure. Here's an example. It even didn't think too much, as you can see. It's already new. Here's an example of how to use the parallel for method to perform parallelism in the rendering loop. Then I'm gonna ask what kind of formats using that ARGB 32-bit as it asks, and which one is doesn't, which type of image file format is using. So we're gonna know just for the future reference, and then when we're gonna integrate that format, we want to make sure that it's supporting the bitmap class of the native dependencies of the C# language. As you can see, it's using the bitmap class throughout, which is the native dependencies of the C#, which is nice. So it's going to be implemented into all kind of devices and platforms that supporting the C#, and the more devices in the future will be supporting the C# because look like it's a great language, and Microsoft is trying to make a Java from the C#, kind of Java similar language to the Java from the C# completely, that's going to support as many devices and platforms as possible, such as operating system, which is great because I love the language and it's easy to use. Okay, it's done. So I'm gonna ask continue real quick, so it's gonna finish the thought. It didn't finish the thought, as you can see. Okay, sure. In this example, the parallel for each method is used to iterate through all tiles in the image in parallel. So it created the tiles even in parallel for each mode. Each iteration of the loop processes the pixels within the corresponding tile. The approach allows for better load balancing. So it's split to us as two different subjects, but over here it put as one subject, which is great. So different approaches put into one approach. So see how I trick the AI. So hopefully guys you're learning, and you can use this approach as not only as a software developer but in all kind of requests to the AI to use it answers and manipulate them to get better answers in your requests. It's worth noting that the tile size can be adjusted to find the best balance between performance and memory usage. Large tile size may improve performance by reducing the overhead of creating and managing threads, but it can also increase the memory usage as more data needs to be stored in memory. On the other hand, a smaller tile size may reduce the memory usage but increase the overhead of creating and managing threads. I don't need to have any overhead. It's important to note that you can use both methods, parallelism in the rendering loop and the load balancing, together to achieve the best performance. This is what it did for us, I believe. The key is to, in the code above, the key is to experiment and find the best balance between performance and memory usage for your specific use case. Keep in mind that this is a simplified example in the real world scenario. So I don't care about the memory usage because I'm going to find out exactly how much memory usage will be for our static scene, for our benchmark. But I care about the threads overhead. So we don't want to have any threads overhead. Keep in mind that this is a simplified example. In real world scenarios, the code would need to handle more complex scenarios such as reflection, refraction. We didn't start that. We're gonna add that in our code and other advanced features. So the code would need to handle more complex scenarios. We're gonna add first these scenarios, and then we're gonna refresh the code. And to refresh the code, I'm going to just ask to update the code with the multi-threaded for the reflection and refraction. Okay, so it gave us the example. Okay, it says it's perfect, but check it out. This is the empty method, but as again, we know this method, trace array, it just didn't regenerate this method, but it's already, we're gonna use that lattice trace array method on top that is generated, is ready for us. It just doesn't want to duplicate the same code over and over again. Okay, so I'm gonna ask what kind of image format supports, and then I'm gonna start adding the reflection and refraction, hopefully in this part of the video. So let's go ahead, and I have no idea what it tells us on top of the image format of the data, but as I told you, here we go. We're gonna ask which format is supporting 32-bit ARGB pixels and which one is don't. And which one is done but could be loaded as image. So, and which one can be accessed the pixel data to access the pixel data, could be loaded to access the pixel data, just to find out the image file format for our future supported file image formats in our application. So I'm gonna ask which image file format supports (32-bit RGB pixel supports pixel data and which file formats we can use that used to access the pixel data from an image with a different data structure that is not in the format of 32-bit RGB pixels. Okay, so just to find out which file formats for the images as the textures. So we're gonna know what kind of image formats our application will support. Okay, the TIFF image format supports 32-bit ARGB pixel data, so we're gonna use TIFF, but it's kind of very large size of the image file format. This format is capable of storing high quality images with large number of colors and high dynamic range. The TIFF file format also supports lossless compression, which means the image data is not degraded when it's saved and loaded, but it's going to be, guys, huge file size. Other common image formats that supports 32-bit ARGB pixel data includes PNG and OpenEXR. For accessing the pixel data from an image with a different data structure that is not in the format of 32-bit ARGB pixels, you can use the DDS. So that's why video games using DDS a lot, especially video games that using the Microsoft DirectX APIs, Direct Draw Surface format. DDS is a format that is mainly used in the gaming industry. Here we go, it tells us. but I already knew that. But look at this, it tells us everything what you need to know. You don't need to go to school, so that's why universities and colleges will be dead, guys, or going to be discounted heavily, and they will promote it. They will get you like, we're gonna give you 90% discount, we're gonna get you a loan as even if you're not capable to get a loan and such and such. You will see it, guys, in the future. This is my prediction. Remember my words and let me know. Anyways, it supports a wide range of image data types such as compressed and uncompressed images. DDS. So DDS is important file format. It also supports mid maps, much better than TIFF. It also supports mid maps, which are multiple versions of the same image at a different resolution. So DDS is much better than TIFF because DDS is kind of smaller file size than TIFF, and it has the additional capabilities and features because it has the mid maps, which are multiple versions of the same image at the different resolutions. So when you're gonna give it the ability for the user to render the image at the custom resolution, which I'm going to do under the custom options, the DDS is better than TIFF. Another format that you can use is the HDF5 format. It is a hierarchical data format that supports a wide range of data types. It also supports parallel input-output and data compressions, which makes it a good choice for large data sets. HDF5, never heard of it before. You can define it when you're gonna use the AI. Please define HDF5. But I'm not gonna do it again. I don't want to be caught in 1 hour of waiting list because I'm recording the video in real time. Makes sense, right, guys? Also, you can use the raw image file format. It is a format that simply stores the pixel data without any headers or metadata. It is mainly used in scientific and medical imaging applications. It can be read and written using basic file input-output function in C, C++, or C#. So guys, as you can see, by watching this video, you learn about image file formats right now. The complex and advanced image file formats. RAW, DDS, TIFF. Alright, so we can use that raw image format. I'm gonna ask, what is the raw image file format? Like which one? There is a multiple raw image file format, as I believe. Like Nikon has NIF, Canon has its own, Sony has its own. You can also use image libraries such as Free Image. I'm aware of that as C# developer. Free Image is nice. It's some API that you can use. Or OpenCV. It's also a great one, but didn't use it too much. I use the Free Image. It's a great. Devil or DevIL. To access the pixel, never use that as well. To access the pixel data from an image with a different data structure and convert it to a format that is compatible with your application. So this type of option is great when you don't know what kind of, where you have like all kind of different image support in your application. But for your scenario, you gotta convert it to some specific image file format to get access to that pixel data and arrays, and then you're gonna use those APIs. But most likely I'm not gonna do that because I'm going to use just couple file formats and it's going to be it. But when you're developing an image processing application, it's a great approach. Let's ask continue, but I think we got an idea. I mean, I don't see to ask, but let's ask continue. Maybe it's gonna provide us additional tips. But I don't see a reason to continue because I got my answer for the file format that we're going to use in our application. Another approach is to use the bitmap object in C# to access the pixel data directly using the logbits method and the bitmap data object. This method allows you to access the pixel data in format of your choice, such as 32 RGB pixels or a different format. Here's an example. Okay, so it gave us a great tip, guys, a great example. of how to use log bits method to access the pixel data of a bitmap. Excellent. So continue is a great command, guys, when using the AI. Just to get additional tips and additional examples. In this example, the log bits method is used to log the image data of the bitmap object, and the bitmap data object is used to access the pixel data. The bytes per pixel variable stores the number of bytes per pixel, and the byte count variable stores the total number of bytes in the image. The pixel array is used to store the pixel data, and the Marshall copy method is used to copy the pixel data between the bitmap object and the pixel array. So explain us the useful log bit method and how to use it. I never heard log bits method, but now I'm gonna know a C#. So it's a great method to use to access all kind of different image data from all kind of different bitmap objects or different file format of the image file formats. For the future reference, I'm gonna know this because I didn't know about that. I just used the bitmap, regular bitmap, but this is the log bits method, which is very advanced and great to use it, as you can see. Once you're done modifying the pixel data, the unlock bits method, never heard about this as well, is used to unlock the image data, and the changes made to the pixel data will be saved to the bitmap object. Okay, so you gotta use that. I just explained to us the code on top, the code snippet. Please keep in mind that this method can be quite low level and requires a good understanding of working with memory and bit manipulations. Let's just continue just in case, so it's gonna define us what it means because I have no idea. Another important thing to keep in mind is that depending on the image file format, you may need to handle endiness and color space conversions. Endiness refers to the order in which bytes are stored in memory, and different image formats may use different endiness. Color space conversion is necessary when the image is stored in a different color space than the one used by your application. By the way, guys, I'm going to start the company, found the company Artistic Bytes as UHDking, and I gotta know everything about that. Artistic Bytes, come on, it's about the image bytes, image file format, and the things that AI just told us, I had no clue before. So it's a great thing that we ask the AI to work with us. So I just from this experiment, I got so much information, guys, to extend my knowledge as C# developer. Hopefully you also receive all kind of different information, no matter what kind of industry you're working with, throughout my videos. So don't forget to smash that like button, support me, guys, and please watch my sponsors, positive comments, share it with your friends, including your forums, my examples. And yeah, I'm gonna make sure that I'm gonna dedicate more time if you're gonna do that. Endless and color space conversions can be handled by using libraries such as FreeImage, DevIL, or OpenCV, or by implementing the conversion algorithms yourself. Additionally, when working with large images, you may need to handle memory constraints and use techniques such as tiling and permit data structures to reduce memory usage. You already told us, we have the example. Tiling for multi-threading, we asked the example above. Tiling is the process of dividing the image into smaller rectangles, or permit data structure are used to store multiple versions of the same image at different resolutions. It's worth noting that there is no one-size-fits-all approach to handle image data. The best approach depends on the specific requirements of your application. It depends what kind of resolution. I think it tell us we're gonna render the final image. It doesn't know, so it tell us this. Choosing the right image format, image library, and technique. I want to try to stay away from image libraries because I want to make no dependencies, because I want to make sure that my application will support as much platform as it could, as much as operating system as it could, as much as devices as it could. And techniques such as styling and pyramid data structure can help you achieve the best performance and memory usage. Let's ask continue. Maybe it's going to give us an example of the code. Another important aspect to consider is the performance of the image processing and rendering. There are several ways to improve the performance of image processing and rendering, such as using SIMD, single instruction multiple data instructions. SIMD instructions allow to perform the same operation on multiple data elements simultaneously, which can significantly improve the performance of image processing and rendering. Using multithreading. By using multithreading, you can split the workload among the multiple cores and improve the performance of image processing and rendering. Using GPU, we already heard this, so I'm going to stop at this point. Using the GPU, I'm not going to use the GPU, but using the GPU graphic processor unit acceleration, modern GPUs are optimized for image processing and rendering, and using the GPU accelerator can significantly improve the performance of image processing and rendering. So guys, when you creating the image processor, such as next Photoshop, you want to use the GPU in your code. And Photoshop didn't took that approach. It's using the CPU instead of GPU. But if you're gonna take that approach using the GPU, you're gonna deliver an application better than Photoshop. Okay? Because it's already optimized. The GPU are already optimized for like probably at least 10-20 times faster than CPU to do the same thing. Using caching. Caching can help you avoid redundant calculations and improve the performance of image processing and rendering. Using data compression. Data compression can help you reduce the amount of data that needs to be stored and transformed, which can improve the performance of image processing and rendering. Using low-level programming. Low-level programming, we have the example on top, can help you achieve the best performance by giving you more control over the memory and hardware, but it can also be more complex and error-prone. It's worth noting that these techniques can be combined to achieve the best performance for your specific use case. For an example, you can use multithreading and SIMD, which stands for single instruction multiple data instructions, together, or you can use GPU acceleration and data compression together. Keep in mind, I'm not going to use the GPU at all. Keep in mind that these are just examples of techniques that you can use to improve the performance of image processing and rendering. There are many other techniques available, and the best approach depends on the specific requirements of your application. Okay, so we heard this already, kind of it was a refresh to us, so we got an idea, but let's go ahead and keep moving. So what I'm gonna do, I wanna ask, remember it told us you can use the raw image format to store the data. I'm not going to store the data, look like. I'm fine with that. I'm gonna store it as regular format, as render, if we're gonna render the final thing. So I'm fine here. I don't need the storing data advanced capabilities yet. So let's go ahead and implement the reflection, and hopefully the AI is not gonna cut us. The OpenAI website not gonna cut us, and we're gonna finish that, and then we're gonna start the new stage, which will be development using the researchers through the AI and verifying the data, implementing it into the C# IDE, and beta test it at the same time. And while creating the beta application that will be usable to any users, and hopefully I'm going to share it with you guys, one of the versions. Extend the code while adding reflection and refraction capabilities as couple of new 3D primitives with applied let's see what kind of colors. With applied colors, with applied what kind of colors we can use? Let's use with applied yellow or gold, and the gold color, gold and red colors. Red colors. Now I wanna do the caustics as well. Example. So what I'm gonna do, because we already have two lights, we have everything ready for caustic. Shadows, we have materials, we have textures. Extend extend add also add additional 3D additional single primitive 3D primitive 3D sphere 3D sphere primitive with the glass with the like glass material feature glass material like feature, and then apply the caustics. I'm gonna do it later on. Let's do not complicate the so extend the code. It's going to be additional code, so it's not going to be too much code, so we're not going to guess too much because it's not commenting every single line. And as again, I'm beginner for the retracing applications. I'm not NVIDIA engineer or something like that. NVIDIA software engineer and NVIDIA retracing engineer that knows how to utilize the retracing capabilities. Extend the code while aiding. As again, this is an example that you can create a professional applications. Start with the basic as foundation and then use the AI to advance it as another stage. And use the AI at every single level. Extend the code while aiding reflection and refraction capabilities. Material capabilities. Material like capabilities as a couple of and apply it to a couple of new 3D primitives with applied gold and red color colors as example. Gold, I'm gonna say metallic. Metallic material. And red color as example. I'm gonna say card paint. Card paint alike as 3ds Max 3D artist. It's going to be complex. As example, also add an additional, as you can see guys, you can create this again an application like 3ds Max Studio or Blender or Cinema 4D just using the AI. You already got a lot of knowledge, as I can see as software developer, from the part 1, part 2, part 3. Just extend it further and you can develop an application. Or develop some custom 3D renderer or something like that. Extend the code while adding reflection and refraction material-like capabilities and apply it to a couple of new 3D primitives with applied gold metallic materials primitives. Then create additional 3D primitives with applied gold metallic material and red color like paint alike as example, while utilizing abilities that we discussed in the code above. So I gotta say apply to a new couple of new 3D primitives as additional 3D primitives on a scene, and then create additional 3D primitives on a scene. So many primitives. Let's see if AI can figure this out. With applied gold metallic material alike. Okay, guys, it's already like 2 hours of recording. Wow. And red colors, card paint. My watch is saying it's 2 hours, but I will keep going until the AI will, OpenAI website will cut us off for 1 hour of break. And red colors, card paint alike. And we're gonna cut this third part of the research with AI videos stage. And red colors, car paint alike as example by utilizing abilities that we discussed in the code earlier as example that was provided by you above. As examples of retracing that was provided by you above. Also add an additional single 3D sphere primitive with a glass material with an emulation of glass material feature. This is going to be complicated, and then I'm going to add the caustics because glass has a lot of caustics to it, but I don't want to complicate it. Let's see if it's going to do the request. This is crazy. Oops, contact us. This is Cuckoo Nunu. Okay, wait a second. Let me copy this. That's a great idea. I think it just got crazy, but it can do it. Come on, AI, come on. Let's ask it again. I know you can. No, there is an error. I know you can do it, buddy. It's just too complicated, I think, for it. So we gotta We gotta make it easy. So let's go ahead and ask to add first reflection and refraction. Extend the code while adding materials. As it was too complicated. As additional. It's not smart enough. It's still the first beta, guys. Public beta. Let's see the first final version. I'm pretty sure it can complete it. It's going to be probably at least 10 times smarter than it is right now. But it's already so good, guys. It's like as minimum 10 professionals in the field, in this particular field that I'm developing, including software developers, retracing professionals, specialists, and all probably in PhD level, because such a questions I'm asking. Extend the code while adding reflection and refraction materials as additional materials to our 3D scene, ray tracing scene, and apply those materials to an additional, so it's not going to use the same 3D primitives, to additional 3D primitives in the different shapes. So we're going to have all kind of different primitives that is capable by default with easy geometry. Let's see, I think it can complete this one. Nope, look like there is an error, guys. We probably need to refresh or something. Maybe we lost the connection. Yeah, we lost the connection, guys, I believe. Let me go ahead and ask what we asked before. First, we're gonna make it so complex. Let's go ahead and do that. Let me get all the way to the bottom. By pressing page down on your keyboard, you can get all the way down. Okay, so this is where we stopped, and then I think we lost the connection because my request is not here. I think we lost the connection to the website. Let's ask that actually that complex thing. I think it can answer, guys. Let's see. Yup, it can. Oh my goodness. I ask, extend the code while adding reflection and refraction material-like capabilities and apply it to the couple of new 3D primitives as I ask add, but as additional 3D primitives. I did a mistake on a scene, and then create additional 3D primitives on a scene with applied gold, metallic material alike, and red colors, car paint alike as example, while utilizing abilities that we discussed in the code earlier as example of retracing that was provided by you above. Also add an additional single 3D sphere primitive with an emulation of the glass material feature. This is such a complex question, guys, and I even did a mistake. I didn't put as, I put at. Let's see if it's going to answer correctly, if it's smart enough. Sure. But it's already, guys, the AI is already smarter than any animal on the planet Earth and any regular human being to answer even this question. Sure, because human being will be, oh, what is the as? It's probably not going to even understand. I said as instead of at, but sure, to add reflection and refraction capabilities to our ray tracer, we can create new classes called reflection material. Look at this, how smart it is, just creating beautiful classes, beautiful named, not like Jamie Coco Nunu or something like that, but you can see on the grid and without any comments. This is going to comment perfectly and going to name it perfectly, those methods and classes, and reflection material that inherit from the material class. So it's going to extend the material class that we already have. These classes will override the shape method to calculate the reflection and refraction rates respectively. So it's going to also override the shape method. Okay. So it's overriding the shape method as well and extending the material class. As you can see, it's done. Okay, this is the example. Good. Press the pause if you're trying to follow it. I will try to finalize as a final code in the final video of the research stage, which will probably this final video or the next one, which is will be the fourth, because we're already at the finalize our basic researches on a retracing application. Then we can create new 3D primitives like a plane and a cylinder and apply the reflection material and refraction material to them respectfully. So it's creating the cylinder and plane. To create additional 3D primitives in the scene with applied gold metallic material alike and red colors car paint alike as examples, we can create new material classes called metallic material and car paint material. Look how smart it is. Beautiful. God, mwah, I love you. OpenAI. You're gonna worth $10 trillion. This is what I'm predicting in 2030. So guys, you better invest in OpenAI, you better invest in NVIDIA, because it's a pioneer of all the pioneers in AI acceleration models, because it's creating the hardware to accelerate the AI to unheard of levels. It's beating the AMD like no other companies, and it's number one on the planet Earth. NVIDIA Corporation. You better buy their classes, their stocks, because guys, it's going to be, there is some other companies will be like OpenAI, but there is no other company that can beat up the NVIDIA in terms of the AI machine learning hardware acceleration capabilities, and this is required for any AI hardware in any data center to perform it as fast as possible. And they're going to compete, guys. It's going to be, as again, other companies like OpenAI. But invest in NVIDIA. In 2027, NVIDIA will worth at least 3 or 5 times, guys, if not 10. It's going to be like a Bitcoin. If AI is going to be adopted, and I don't see the reason why it's not going to be adopted, unless your company is under the rock, and that company will be out of the business by 2024. Okay, let me know if I was right with my predictions in the comments by visiting my YouTube channel in 2024 and 2030 or 2027, if NVIDIA stocks will be 5 times from today. As example, we can create new material classes called metallic material and car paint material that inherit from the material class and apply them to a new sphere primitive. Okay, then I asked the glass. Remember the glass primitive as well as sphere? Data. Here's the code of that metallic material and car paint material. Okay, it's done. Nope, it's not done. It didn't close the car paint material class. So I'm gonna ask continue. As you can see, continue. Here we go, and it's gonna finish the thought. Yep, it's continue. Create a sphere and apply the metallic material. I really like how they fix. I really like, guys, how they fix the ability when it's continued the thought. So it's not continued the thought, but it's continued the sentence or continued the part of the code, so you're not gonna get confused. And I think this is the newer version, but it's still saying January 9 version. But I think AI, even in this version, is extend its knowledge, because January 9 version wasn't like that. So when it's continued the thought, it didn't do something like that. Oops. Okay, let's refresh that. There is an error. Okay, there is an error. Let's I'm gonna go and I'm gonna page down all the way down on the keyboard, and I'm gonna say refresh the continue, as again pressing by this icon, save and submit. This is the way when it's an error, and instead of real login you can do it. Sometimes real login doesn't work, but this method works, what I learned. So this additional tip for you how to fix that error that AI generates, and it's asking you to contact their customer support service. You know, it's a line, it's a million of requests. So this is how to get rid of it and continue. To create an additional single 3D sphere primitive with emulation of the glass material, remember I asked the glass material feature, we can create new material class called glass material to inherit that inherits from the material class. This class will override the shade as again. Let me see. This class will override the shade method to calculate the refracted and refracted rays and combine the colors to emulate the effect of glass material. Glass material. Okay, pretty simple. Look at this. To create the glass sphere, created the material, but did it create it new material class? Data data data. This class will override data data data. A method to calculate the shade method to calculate reflected and refracted rays and combine their colors to emulate the effect of glass material. But where's the sphere? Did it create the sphere? I probably should ask continue. Oh no, it did. Then we can create a new sphere and apply the glass material to it. Beautiful. Look at this. Example, how to create a new 3D primitive and how to apply the material, the custom material from your code. Please keep in mind that this is a simplified example of how to emulate the glass material in reality. The glass material is very complex and there are many factors that affect its behavior, such as surface roughness, the absorption, the dispersion, and anisotropy. I know what is anisotropy kind as 3D artist, but I never heard the roughness kind of surface roughness as 3ds Max user. I know kinda as 3D animator and 3D artist, but the absorption and disruption have no idea what it is. Even 3ds Max doesn't use it for the glass. There are many different techniques and models that can be used to emulate the glass material, and the best approach depends on the specific requirements of your application. And I believe there is also caustics, because the glass costs a lot of caustics. So we probably I probably should ask continue. Probably gonna give us an example. Let's ask continue. I was gonna say, you know what, you better read the books and data. When it does like that, it doesn't know where to look, the clue. That's it, guys. Menu request, tere. And unfortunately, we cannot pass this, even with this type of approach. Or can? We can! Oh my god! I just learned how to avoid that limitation, guys, in the free OpenAI ChatGPT, and hopefully this tip will help you out, because I'm pretty sure when they're going to release the pro version, it's going to be limited and you cannot pass. It's going to be limitation by 1 hour, and this is the limitation actually of the free version, but I just show you an example how you can pass that limitation. Okay, in addition to the glass material class, you can also consider adding some additional features, such as implement partial equation to the reflection material and refraction material classes to calculate the amount of refraction and refraction based on the angle of the incidence. Implement Schlick's, I have no idea what it is, probably a computer scientist, approximation for the partial equation for faster performance. Okay, so right now it's talking about the optimization. Let's focus on the optimization. Implement a way to handle transparency and translucency of the material. Implement a way to handle the surface roughness of the material. Implement a way to handle the absorption of the material. All of these features will help to improve the realism of the render image and give you more control over the material properties. It's worth noting that all the code provided above is a simplified example of ray tracer and there is a lot of more to consider when implementing a full-featured and production-ready renderer. However, it can serve as good starting point for understanding the basic concept of ray tracing and how to implement it in C#. So guys, as you can see, you can create your rendering plugins, ray tracing rendering plugins, maybe not using the CPU, maybe just use the GPU, or maybe use both CPU and GPU, but GPU through the RTX technology by the NVIDIA. And you can create by using the ChatGPT for 3ds Max or Blender. I'm pretty sure it's going to be easy because it's going to tell you the knowledge all about the Blender and 3ds Max Studio, and I'm pretty sure it has no problem to do that. So giving you some clues and some ideas for your own adventures and developments, guys, as software developer. I'm pretty sure the world in 1 year from now, from today, will improve to the level like all the plugins for all kinds of different softwares, while people will use the ChatGPT. It's going to be just unheard of, millions of the guys plugins in the future, because you can create in a few days. Photoshop plugins, for example. So a lot of tips, clues I'm giving you guys. Don't forget to smash that like button. And I gave you the tip how to avoid that limitation that I learned. So at least you're learning by watching my video. Anyways, let's get back. Also, please keep in mind that the code snippet I provided might not be completely functional, as it might contain error, and it also might require additional code to work as expected. I don't think it was with any errors by looking at the code, but let's continue. If it was any errors, the AI can correct it. As again, I told you, it has the ability, even in this January free public beta version of the January 2023 of ChatGPT by OpenAI. But let's go ahead and have a look. I'm pretty sure it's going to provide us some great tips right now. Another important aspect to consider when data implementing a ray tracer is the acceleration structure. An acceleration structure is the data structure that is used to speed up the intersection tests between the rays and the scene objects. I believe that Jensen Huang from NVIDIA was saying about it on one of his presentation of the RTX technology on the RTX 3000 series GPUs and 3000 series, which is the Ampere GPUs by NVIDIA, or RTX 3000 series video cards. There are several types of acceleration structures, such as, okay, it told us already about that. Each of these acceleration structure has its own advantages and disadvantages. Those methods such as octree, grid, KD tree, bounding volume hierarchy, which is BVH. Never heard about them, but okay. For example, BVH is popular and simple acceleration structure that is easy to implement and can work well with dynamic scenes, but it can be less efficient than other structures when the scene is static. Octree is another popular acceleration structure that is efficient for the sparse scenes, but it can be more complex to implement than BVH. Grid is efficient for dense scenes, but can be less flexible than other structures. When implementing an acceleration structure, it's important to consider the memory and CPU usage and complexity of the implementation and flexibility of the structure. Well, I don't care about CPU usage. I want to use my CPU usage at 100%. I hope this information helps you to understand how to extend your ray tracing code and add additional features as capabilities. If you have any further questions and concerns, feel free to ask. Well, I don't care about optimization right now. It's going to be under the advanced stages of this project, which will be multi-part videos as well. So we did that. Let's go ahead and add the global elimination, guys. Alright. So what I'm gonna say, extend the code while editing. There's going to be crazy. Global illumination to our 3D ray tracing scene, and make sure that it will be integrated with the code snippets above in this project, in this ray tracing project. Okay, this is crazy stuff right here. Global illumination, GI. Complex lightings, guys. Sure, to add global illumination to our 3D ray tracing scene, we can use several techniques such as path tracing, photon mapping, and Jesus, so much new stuff for me, and bidirectional path tracing. Path tracing is a simple and popular technique that involves tracing rays from the camera and simulating. So you gotta have the camera before asking such stuff like that, and I already added the camera, and simulating the light bouncing with the scene. The more bounces a ray takes, the more accurate the final image will be, but the longer it will take to render. Okay, it's give us the basic class, and it's so simple. Let's override the shade class. It's overrides. Then it gives us the photon mapping. So the photon mapping is more advanced technique that involves tracing photons from the light sources and simulating the light bounces within the scene. Photons are stored in a data structure called a photon map, which can be used to estimate the indirect light in a scene. Bidirectional path tracing is more advanced technique that involves tracing rays from the camera and from the light sources at the same time. This technique can produce very high quality images, bidirectional path tracing, but it can be more complex to implement than path tracing or photon mapping. Well, AI, you're gonna implement it for us, so I don't care how complex it is. It's free, and as complex as it's gonna get. All for me it will take just copy and paste, and it give us the example. Check it out, which is longer but pretty simple to understand with beautiful comments. You can choose which techniques. So 3 examples, beautiful, that fits your need and integrated with the code snippets that we discussed before. It's important to note that GI, or global illumination, is a complex topic, and there are many factors that affect its behavior, such as the number of light bounces, the number of photons, the size of photon map, and the number of samples. To achieve a high quality image, you will need to experiment with the different settings and parameters. Also, this code snippets are a simplified example of how to implement global illumination, and it might require, and let's just continue. So you can see it didn't finish the thought. Additional code to work correctly in real world scenario. To integrate global illumination with the code snippets that we discussed before, you can make the following changes. Create a new class for each of the global illumination techniques: path tracing, photon mapping, bidirectional path tracing, that inherits from the material class and overrides the shade method. Okay, show us the example. Create an instance of new material class and apply it to the object to objects in the scene. In the case of path tracing and bidirectional path tracing, you will need to add a recursion limit to the trace ray method to prevent infinite recursion. In the case of photon mapping, you will need to create a photon map data structure and implement methods to trace photons and look up indirect light in the map. You will also need to experiment with different settings such as number of samples, the number of bounces, and the size of the photon map to achieve the desired quality and performance. Here's an example how to integrate the path tracing with the code snippets we discussed before. Okay, extending the material class as path tracing material. Okay, give us an example. Excellent. But it didn't close this class. Actually, it did. It did close the class. So this is okay. It's worth noting that the code I provided is a simplified example of how to implement global illumination. In reality, there is many factors that affect the performance and quality of the image, and the best approach, we already learned the samples of the photons. But to be exact, I have no idea what it's talking about. My brain do not visualize the image. And the best approach depends on the specific requirements of your application. Okay, so there is, when it's stating something like that, that means there is additional something. Let's ask to add the samples. Path tracing, photon mapping by the samples. It's did the samples. Photon mapping is more advanced technique. Guys, we have a big snowstorm and so cold. I better go ahead and put the heater on a higher temperature in the house. But the more bounces a ray takes, the more accurate the final image will be. It was talking about the let me see, it was talking about the samples right here. Did it give us the sample example? If not, I'm going to ask to give us some sample example. Okay, let me go ahead and ask. Right here. Let's copy this. 1 second, guys. I'm gonna ask continue if it's going to stop. Look like it's finalized for us, but if it's not going to give us any other tips, I'm gonna ask to give us an example of the snippet, of the code snippet with the example of those samples and whatever it was talking, because I have no idea as 3D artist, and as again a software developer, I never developed any game engine or ray tracing, path tracing application that's going to support those features or capabilities. And I'm not an NVIDIA engineer. I know the ray tracing from the point of the gamer. So other important considerations when integrating global illumination with the code snippets we discussed before include the following. Handling the direct lighting, you will need to handle the direct lighting in addition to the indirect lighting in order to achieve realistic image. So I'm going to ask how to do that. How to handle the direct lighting in addition to the indirect lighting in order to achieve realistic image. I'm going to ask the example actually. You can do this by adding a diffuse and specular component to the material classes. I believe we already done so. at the beginning when we were creating this basic code in the part 1 of the researches, when AI created the basic code when it's added the diffuse and specular material classes and using the font reflection model. We didn't do that yet. And the Cook Torrance reflection model, look like a computer scientists, to calculate the direct lighting. So I'm going to ask the examples actually. Handling of that, because I have no idea what it's talking about. Handling the environment lighting, you can add a skybox, an environment map to the scene to simulate the lighting from the environment. Okay, this is what I learned from the 3ds Max Studio application, 3D rendering application for the 3D animations and 3D rendering. So we're gonna ask how to create the environment map example as well. This can be done by adding a new material class for the environment and using the environment map or skybox texture in the shade method. Handling caustics. Caustics are the light patterns that are created. Remember I told you when we were creating the glass? Next I'm going to do the caustics, and now it's talking about the caustics. So my approach as understanding as a gamer of the ray tracing was correct. Handling the caustics. Caustics are the light patterns that are created by, as a gamer and as again as 3D artist, I know the basics at least about the caustics, that are created by the refraction and reflection of light through a transparent and reflection surface. You can simulate acoustics by tracing a separate set of rays for acoustics and storing them into separate data structure. All of these factors will help to improve the realism of the rendering image and give you more control over the light, over the lighting and material properties. It's worth noting that global illumination is a complex topic, and implementing a full-feature global illumination render can be a challenging task. Nothing can be challenging for the AI, right AI? But understanding the basic concept and techniques can help you to achieve a good starting point for your project. Keep in mind that the code snippets I provided are just examples, and the final implementation might require additional code and optimizations to work correctly in real world scenario. Okay. So I copied something that I about to ask AI before we're gonna ask the other example. You can choose the techniques that fits your need to integrate it with the code snippets that we discussed before. It's important to note that global illumination is complex topic. Let's ask the technique. Example of the technique. That effect is that will example of the number of light bounces. Yeah, you can choose. Okay, so I'm gonna say show extend the code and integrate number of light bounces, number of photons, the size of the photon map, or the number of samples as examples. Here we go, guys. Sure, it integrates the number of light bounces, the number of photons, the size of the photon map, and the number of samples into our code. Remember, I want to have those samples. I learned from that Polish software developer in Java Retracer that samples are important. We can use properties and but I couldn't understand the samples. Now it's better idea because that developer didn't comment the code pretty well. We can use the properties and variables to store these values and use them in the appropriate methods. For example, in the case of path tracing, we can add a new property called max bounces to the path tracing material class. Okay, and use it to limit the number of bounces in the trace ray method. Okay, as you can see, we're extending the class material with the path tracing material. Data. In the case of photon mapping, we can add properties called number photons and photon map size. From the Elon Musk, I learned that every single photon also has the vibrations and it's going to reflect differently based on the vibration cycle of those photons. In the case of photon mapping, we can add new properties called number photons and photon map size to the photon mapping material class and use them to control the number of photons that are traced and the size of the photon map. I have no idea what it's talking about, so we're gonna find out while integrating that and play with the scene while we're going to use it in beta stages and see how it's going to render for our brain to create a visual image of what's going on. In the case of bidirectional path tracing, we can add a new property called num samples to the bidirectional path tracing material class. So we created additional class, as you can see, bidirectional path tracing material, and use it to control the number of samples that are taken in the shade method. Here we go. And then finish that. I'm going to ask continue. Guys, I better grab another coffee. It is 4 a.m. 1 hour, limit us. Let's go ahead and pass this with the limitation as I taught you. Ta-da! Nope, not passing. Let's go ahead and do the reload. Boom, boom. And we're gonna page down. Click somewhere in the white space and page down all the way. Keyboard button on your keyboard. And you're gonna ask continue again. Let's see if it's going to work. Nope. It tells us cuckoo no cuckoo. Nope. Sorry, it's not going to work out that way. The AI is AI. It's probably learned that we found a. But what about if I'm going to say explain more instead of continue? Or I'm gonna say continue explain more. Different way to ask. Nope. That's it, guys. Look like this part 3 will be done. Okay, this is the part 3 of the research with the AI towards UHDking's ray tracing CPU benchmark. So it's going to be part 4. As you can see, AI learned and it doesn't allow us to pass this point. Let me go like that. Let's try it again for the last time. If it's not going to do and I'm sleepy already, I better catch some sleep. But let's go down. Maybe it's going to help us. Maybe not. Continue. I'm gonna say count. Nope. It's done. So we're gonna come back in 1 hour. So this is limitation of free public version. But I taught you how to pass the limitation. Maybe it's going to work out, maybe not. Maybe it's only working once, or maybe AI learned through the machine learning. This is how I'm passing the restriction that limit us. Do not use the server until the while waiting 1 hour and then come back, because too many requests. It completely makes sense. That's how they're gonna make money through the pro version, when they're gonna limit that restriction to limited amount of people that will pay a monthly fee. Alright, so hopefully you enjoyed this video. As again, the audio track is all right reserved. I have the commercial license. You cannot claim any royalties. And my name is UHDking, or I play 4K, aka I play 8K, aka I play 16K. Hopefully you enjoyed that. Don't forget to smash that like button. A lot of time, money, energy was invested. Share it with your friends, and positive comments. Visit my sponsor. So I'm gonna collect those pennies, and I'm going to create more computer science tutorials, videos, while sharing a lot of information and value back to you guys. And besides the gaming videos, 16K video resolution videos, uh, graphics design tutorials, 3D animation and 3D modeling tutorials, I'm looking for your support, guys. As you can see, this channel is unique, valuable. You're learning. I'm providing a lot of value. As again, UHD King. Have a good morning, good day, good evening, good night. Till the next time.